PowerShell scripting, debugging techniques. Now, believe it or not, one of the things I love most about PowerShell, about computer programming in general, is debugging. And that sounded a lot cooler in my head than it did out loud just now. But the debugging is cool. It's like getting a puzzle for Christmas, and you can sit down and kind of put the pieces together. Only in the case of debugging, sometimes you're not really putting the puzzle together so much as taking it apart to see why it works and to find the bits of it that aren't working. In fact, if you can remember that little analogy, you'll be a master debugger in no time. So in this nugget, we'll talk first about the purpose of debugging. And I'm actually going to kind of walk you through a little exercise that I often do whenever I've got a script that I've got a problem with, whether it's my script or more often someone that I've downloaded, stolen or, repurposed off of the internet. Then I'll show you the actual techniques. We'll talk about writing debug information to the screen, using breakpoints in the integrated scripting environment, and using breakpoints right at the console. Whenever I'm confronted with a new script, and quite frankly, even if it's a script that I myself wrote 6 months ago, today it's a new script. I like to just take a minute and sit back and think about what I think the script is going to do. Here's the thing. There's a couple of types of bugs in the world. Simple bugs are typos. Right now that I've deleted that little curly bracket, you'll notice I get this curly squiggly here in the ISE, missing your closing bracket. Okay, now I need to go figure out where the bracket is. This functionality is the same in PowerShell version 2, by the way. It's prettier in PowerShell version 3, and there are third-party editors that do an even prettier job of this, but the basic thing here is that syntax errors are just typos. PowerShell will help you find them as much as possible. We're not even going to spend a lot of time on them because, you just have to get the typing right. An easy way for me in this case to fix it is to just take a look at the structure of the thing, because I've been very careful to indent each time I got into a curly bracket. It's kind of glaringly obvious here. I also don't do the thing some folks will do. Well, they'll close several different curly bracket sections on one line like this. I don't like that. I like each closing one to be on a line by itself so that I can very clearly see when one is missing. So anyway, typos are typos. You know, if you whack a quotation mark here, for example, all the color coding goes crazy, and you get the red curlies, and the string is missing the terminator, double quote. Oh, so somewhere I've got a string that's missing a double quote, and there it is. So typos are typos. Typos aren't really the difficult type of bug defects. A bug is more of a logic error. It means that whoever wrote the script made an assumption about something, and they were wrong. Reality doesn't match. Now, sometimes it's not their fault. If you're repurposing, if you're repurposing someone else's script, it's possible that whatever operating system version they wrote it for, their assumptions were correct. I'll give you a really good example. Let's pop open the shell here for a second. Get WMI object Win32 processor. Now this shows that I have one processor, and I'm going to do a formatless star so we can see all of its little properties here, because this is kind of cool. I have one core, and I have one logical processor in that core. Now I'm running in a virtual machine. That's the only way that can happen. The Win32 processor class actually changed. When Windows XP first shipped, you got one of these processor objects for each core in the computer. Because when Windows XP first shipped, you only had one core in any given socket. We didn't have multi-core processors. Well, at some point, Microsoft changed the way this thing works, and they added this number of logical processors and number of cores thing. So this can tell me on a dual core proc, I get one, oops, didn't mean to grab that. I get one of these processor objects per socket. It will then tell me how many cores, and based on hyperthreading, it will tell me how many logical processors I have. So if this was a single socket, dual core, that would say 2. And if it was hyperthreading, that would say 4, because hyperthreading logically doubles the number of processors. So the point is that if you wrote a script based on assumptions for the original XP, or for an earlier version of Windows, like Windows 2000, that same script might not run correctly on a later version of Windows because the assumptions changed. So I like to sit down with every new script and just think about what it is actually doing. And I will go so far as to open up a copy of Notepad, Actually, I'm a little ashamed to admit it, but a lot of times I will get a piece of graphite and a piece of dead tree, pencil and paper to you, and I will actually write all this down on paper as I go through the script. So if I run this, now first of all, I know if I run this script, nothing is going to happen because I'm defining a function, but I'm not actually calling the function, right? So at the bottom of the script, if I want to test this, I've got to call the function get dash low disk capacity. Takes a parameter computer name. We'll give it localhost. And how about dc.lab.pri? Give it a couple. So when I run this with those values, the first thing I need to consider is how those values are being passed into line 5. So on line 5, I believe computer name contains a collection of objects with localhost and dc.lab.pri. Now I just kind of tend to use PowerShell's syntax for an array. You don't have to. This is just for your benefit. You could type computer name is an array that has 2 values. Right? You can type this out however you want to. The point of these notes off to the side is for you to keep track of what you think is happening in the computer's head. So the first executable line of code is on line 8. So now I'm using this for each construct. That means the first time through, computer is going to be localhost. Okay? In fact, I'm going to make a note that this is the first time through. First time through. Now the second executable line is number 9. Disk is equal to get wMyObject. So I'm retrieving Win32 logical disk. I've put a filter in here so that I only get drives with a drive type property of fixed. Okay, I mean that seems reasonable. I guess I don't want to check network drives from whatever computer. So I'm going to assume that disk contains a disk object for a hard disk. Now next, I'm going to say line 10, if disk free space divided by disk space, oh I see, we're getting a percentage. Okay, so 90% 3 would be 0.9 because we're doing, and you know, here, let's just test this. If the thing contains 500 gigabytes and there are 20 gigabytes free, then free space 20 divided by 500 total, 0.04, that would be 4%. Okay, so the math here looks right to me. It's saying if it's less than 0.2, which would be 20%, so I'm assuming disk has a free space and what was the other space? And space property. Just writing down assumptions. Now I can see a problem right here already. The next executable line of code, if the free space divided by space is less than 0.2, meaning less than 20% free space, then I'm going to execute this. If it's not, I'm not going to do anything. Now that means when I test this, if I don't have any test machines that meet this criteria, I'm not going to get any output. So right now, I'm going to change this to less than 1. Meaning, if it has less than 100% free space, I want you to output the device ID, free space, and space properties. Okay, so that's another one. Free space, device ID. Again, documenting my assumptions, and notice that I changed this. In fact, just to remind myself that I did that, I'm not saying I've never forgotten to do this. There, just so I remember. So my presumption here is that if a server has got multiple disks that have any amount of free space because of the change I've made, then each of those should output. So real quick, I'm going to flip over to the console. And I think I just want to try making sure that my DC is online. Let's not debug more than one thing at a time. Okay, it's online. Good. Well, let's run the script then and see what happens. Whoa, 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 whoa. Angry red text. Bug, 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 bug. Invalid query. Yikes. Okay. Well, that means I've got bad assumptions. The first thing I need to deal with, obviously, are the obvious error messages that PowerShell chucks out. So let's open up a console, and what I like to do is get out of the script. I want to get completely outside the script. What I want to do is run this command the same way that the script is running it, but I want to kind of simplify it. So let's just start with this. Let's see if this works. Copy, paste, enter. Okay, that works fine. Now let's add on a computer name. Computer name dc.lab.pri. Okay, that works. Now let's add on another component. Minus filter, drive type equals fixed. Invalid query. Okay, this worked. This much worked. This didn't. You see, by going at this one piece at a time, I've figured out what bit of this doesn't work. Now we've got a thing here. I have to decide, is the minus filter parameter just wrong? Well, I can determine that by letting PowerShell tab complete it. Minus F. Nope, that's right. That means what's in here has got to be wrong. I need to look and see what actual type of data is included in that drive type property. And if you look up here, drive type equals 5, drive type equals 3, drive type equals 2, they appear to be numbers. So this script made a bad assumption about the data that was contained in here. Another way I would do this is to get everything back with no filters and pipe it to format list star. You get a lot of output there, but it's going to show me every single property and the type of data that is in that property. So I'm not making assumptions. In other words, I can see, if we scroll down a little bit, I can see that the drive type contains 5. It doesn't say optical. For this, let's go, here's my local fixed disk. The word fixed is in the description. The drive type for that is actually 3. Great, I think I found a problem. So I'm going to go back and make one change. I'm going to change this string fixed to the number 3. I'm going to save it, and making that one change, I'm going to run the script again. Okay, now I've got an attempt to divide by 0. I'm not going to go back and undo my old change. That change seems to have done something effective, and I can verify it by coming down here and running. Yeah, that actually works. So if I'm getting back drive type 3, then I'm getting back a good object. Now I still have another problem here, which is attempt to divide by 0. I'm only doing division in one spot here. I mean, I can see that the size is, oh, wait a minute. Size has a number. What does space contain? Oh, there is no property called space. Yeah, here's a little ugly thing about PowerShell. Let's run that whole command again, where we retrieve the disk information, save it in a variable, and then ask for disk.space. Nothing. It doesn't complain though. So I wind up getting an error because this evaluates to nothing, meaning I'm trying to divide by 0. I probably meant for this to be size. Now, if you'll notice in my assumptions, it means I actually have a size property, and there was somewhere else where this showed up. So I need to make sure I change it there as well. So I fixed another bad assumption. Let's run it again. Now I get my 2 bits of output. So you can see that the process of walking through the script really does kind of force you to document your assumptions, I guess you should say. It forces you to think about the script, and then when you run into a problem, you can revisit those assumptions. You take individual commands out of the script and you test them on their own so that you can figure out if they're running the way they should or not. You can figure out if they're written correctly. Get them out of the script so that they're not surrounded by all these other pieces of functionality, so you can test them just entirely on their own. Now I'm going to take my 1 out and put a 0.2 back in, because if I'm right, this should now produce no output, and that should be what I expect to happen. Yep, that is what I expected, because none of my disks had that little free space. So this is now working well. I'm going to remove this command that I added for testing, put the script back in its original situation, because I want to move on to a different and somewhat more difficult type of error and show you how to deal with that. This is a function very similar to that last one. It's called getSystemInfo, also accepts a computer name, goes through each computer one at a time, and appears to retrieve information from 4 different WMI classes. Now there's no filters here, so at least I don't have to worry about that. It's got an if block here. It's comparing the OS architecture property of the Win32 operating system object to the address width property of the Win32 processor. And I'm guessing what it's trying to do is decide if the OS is 64-bit and the processor is 64-bit. And I guess what you would want to do is if, let's see, if the OS architecture was 32 and the processor was 64, this would be false, and so we're going to set this thing called optimal, just a variable, to false. Otherwise, we set it to true. So I guess you want to know if you've got 32-bit operating system running on 64-bit hardware. Seems like a waste, so you'd want to know. Then it's assembling a bunch of information together into a custom output object, which it is outputting to the pipeline. So let's just add a little line to test this. Get systeminfo, computer name, dc.lab.pri. And we'll do localhost as well. What the heck? Let's run it. Okay, yeah, we got some problems here. First of all, optimal architecture is coming across as false, but the processor architecture is 64 and the OS architecture is. Right away, I can see the problem here is it's comparing 64-bit to 64. And those are not equal values. Obviously, those are different strings. So I'm going to have to make some changes. It looks like everything else is kind of sort of working okay. You know, let's get in here and play with this a bit because I want to show you another way of getting inside a script's head. And I'm going to get in here and use the command write debug. And I do tend to put some white space on either side of this. That's why I've got those blank lines there. Finished getting WMI objects. This is a pretty neat little thing. I'll also use write verbose a lot. So by putting that in double quotes, it's going to give me the computer name it's querying. And I use these in a couple of different ways. And the last thing I'm going to do, right now this new object command is producing an object and it's pumping it directly to the pipeline. I kind of don't want that. I want to stick it in a variable so that I can do another write debug. And then write that out to the pipeline. I kind of want to step between creating it and writing it to the pipeline so that I can have this in the middle, and I'll show you what that does. Now look, this is going to be easy for me because my function has this commandlet binding right before the parameter block. If that wasn't there, then at the top of my script I would need to put this, because by default write debug is disabled and this enables it. Write verbose is also disabled by default, so I would need to make it continue as well. But because my script has commandlet binding, or because my function does, I don't need to do either of those things. Just when I run this, I'll add minus verbose and minus debug. In a command that supports commandlet binding, using minus verbose and minus debug turns on the equivalent commands. So let's run this. There's my verbose output. It says querying dc.lab.pri, and then my debug output kicks in. Finished getting the WMI objects. What do you want to do? This is the neat thing about write debug. Do you want to continue? Do you want to suspend the command? That's what I want to do. I want to suspend the command. You'll notice that my prompt is just a little bit different. It's got that double angle bracket. That means I'm inside my script's head. Look what I can do. I can say, show me the entire OS object. All right. What is os.os architecture? Oh, it's 64-bit. I already figured out that's not going to work. What if I take that and replace any occurrences of -bit with nothing? What do I get then? Ooh, I get 64. That'll help. And what type of data is that? Let's pipe it to get member. We'll scroll up a bit. Okay, that's a string. Now, proc address width was 64, and what's that? Oh, that looks like a number. Yeah, that's an integer. I wonder if we can cast that as a string and turn it into a string. Yep, we sure can. So that might be a couple clues for fixing my comparison problem in there. I can also just take a look at what was in the processor object. Yep, that's what I expected. What about BIOS? Did we get something useful in there? Yeah. And what about the other one was comp? Yeah, so all those things appear to have good information in them. So let's exit, and we're going to come back, and now I'll say, yes, I want to continue. And we'll continue again. So we're continuing to query is what's happening here. I produced our custom object, so there we go, optimal objects. All right. You know, that was useful to get inside the script's head because now I think I know the solution here. So we're going to say if OS architecture, I'm going to do a little sub expression, replace minus bit with nothing is not equal to this cast as a string. Now let's run this again. Yep, you can continue. Produce the custom object, yep, continue. Querying localhost, yep, continue. Continue. And yeah, it looks like everything's good. I'm going to prove it just by going and taking off the debug and the verbose. See, a lot of scripters will get used to putting in this kind of, I call it debug output. They'll put some echo statements or something in there just to let them know what's happening in the script and to give them a chance to stop and examine things. But when you get done debugging, you have to go take all that garbage out or comment it out. Well, with PowerShell, you don't have to. If you use write debug and write verbose this way, you can turn that output off by simply not running the command with verbose and debug. So now when I run this, it just runs. There's my first computer and my second one, and it looks like my comparison turned out to be true. So that's a really, really neat little trick. Now, there's a total different way I could have arrived at that same conclusion. I'm going to go take out my write verboses and write debugs, and I'm going to show you ISE breakpoints. Now, what I like to do here is every single time my script changes a bunch of variables or relies on anything, I like to stop. So I'm going to put a breakpoint right here, and you do that on the debug menu with toggle breakpoint, or you can hit F9. And sometimes if you select the entire line, it'll put the breakpoint on the next one. So I'm going to take it off. You really just want to put the cursor on the line and hit F9. Now you'll notice that's highlighted in a dark red now. That tells me that there's a breakpoint there. And let's put another one out here. So those breakpoints are going to kick in before it executes the highlighted line. So now let's run. We hit a line breakpoint. You see I get that same prompt over here, but look what happens back in the editor. Now it's highlighted in like baby puke color. What's actually happening is it's going to try and highlight the current line in yellow, and that line is also a breakpoint. So the yellow and the red combine to form baby puke color. Here's a neat thing you can do though. I'll hover over this variable. Oops, get into the script. And if I get down to a standard variable and I point at it, I should get a tooltip, which my computer doesn't want to do right now. Yeah, it doesn't want to. But if I wanted to look at one of these, I don't know why it doesn't want to do that. I can still go back to the console and I can say, show me what optimal contains at this point. No, it's true. I can actually get a directory of the entire variable drive and look at every single variable that has been defined and is being used inside of this script. It's a complete dump of variables. Really cool trick. And when I'm finished, I can hit F5 to continue. You can also do this neat thing called step into and step over. I'm going to use F11 to step into and watch what happens. It moved to the next line of code. Now it's on write output obj, and I hit F11, and now it's executing this. And now you'll see, because I'm in execution mode, I'm not actually broken at a breakpoint. my little tooltips working. So it's telling me, okay, here's the value that's in computer. So I'm going to come down here and let's just validate. Yeah, but now it's localhost. Okay, so I'm going to run that. And now here's what's in OS because it ran that line. So I'll run the next line. That's what's in computer. So this whole step at a time execution is really cool. Once you've validated a couple pieces of information, you can just hit F5 and it'll go down to the next breakpoint. Well, let's go ahead and remove that breakpoint. Hit F5 again. I'll remove that one. I'm just hitting F9, hit F5 again, and it should run through my entire script, and if I switch back to the console pane, I'll see all of my output. Sometimes when you're doing that, it can be useful to put the ISE into this side-by-side mode, and I'll show you why. Now, if I want to run this, I'll just hit F5 again. I can see it next to it. I can see what's happening. So if I were to put a breakpoint here with F9, run it again, I can see the output as it's happening. And now I can F11 through here. And it's about to write my output object. And there it goes. I can see it over on the left-hand side. So that's a really neat trick. Let's go to the debug menu. Stop the debugger. It's going to cancel my script. And I'll remove this breakpoint. Now, those breakpoints within the ISE are useful, these graphical breakpoints. But really what's happening under the hood is I'm just letting the ISE run a bunch of PS breakpoint commands. Set PS breakpoint creates a new PS breakpoint. I'll show you how this works in a different way. Set PS breakpoint. I want to tie this to a specific script, which is going to be my cdebug PS1. So this breakpoint's only going to apply to that file. And let's see, I want this to be a variable breakpoint. Now what I was setting before was a breakpoint on a particular line of code. Now I want to set a breakpoint on the obj variable, and I want you to break whenever that variable is read or written. It has now created that breakpoint. Now look what happens when I run my script again. I hit a variable breakpoint, and look over here in the ISE. See, the ISE doesn't give you a graphical way of creating variable breakpoints, but it does respond to them. It knows that I'm on line 28, and I try to do something to the obj variable. Okay, well, let's F11. Let it happen. What's in obj now? Okay, that's what I expected, so we'll hit F11 again. We hit another breakpoint because now I'm trying to read obj, but that's okay. I want to let it continue. And we'll hit F5 to run until it hits the next breakpoint. That's perfect. You know what? I think I'm good. Let's get PS breakpoint and remove PS breakpoint. That's going to remove them all. So now when I hit F5, my script should complete without hitting any more breakpoints because there are no more. So these breakpoints can be really, really super, super useful. In fact, if you look at the help for set PS breakpoint, you can set one on a script, right? Each of these lets you specify it for a specific script, to a line and a column, to a particular command that gets executed, or to a variable, and you can specify a mode, read, write, or read-write. And if you don't want it to actually break and go into that interactive debugging, you can provide a script block as an action. Let's try that for a second. I'm going to make this a little bit bigger. Set PS breakpoint on the script debug.ps1. Let's see, what do we want to do? Oh, I know. Let's say on the command get wmy_object, right? I'm just playing around here. We'll see what happens. I know this takes a script block, so I'm going to send computer out file debug.txt append. No idea if that's going to work or not. Just going to have to run it and try. Now, so you'll notice it ran my script without actually breaking, and that's because I provided an action. When you provide that action variable to the breakpoint, it says don't actually break interactively. Let's see if I got a debug.txt. Yep, there it is. Get content debug.txt. Whoops. and it wrote all the information. And so that script block that I provided to action, let's pull that up again. This is the command I ran to set the breakpoint. And I specified an action in a script block, and that script block runs in the scope of your script, meaning it has access to all of your script's variables. So when might you use this? Well, let's say you're running a script as a scheduled task on a server at night. You're not going to be there, but you want to find out what's going on. Maybe it's running into problems. Well, you can set up these breakpoints that are completely automated, and they log information, in this case, to a file, because that's what I had it do. Now I'm going to remove that. And now the breakpoint won't occur anymore. Now these breakpoints aren't universal, and they're not attached to the script file. The breakpoint only lives for the duration of my current PowerShell session. So if you wanted to have this happen on a script that was running, say, as a scheduled task, you would need to define the set breakpoint commands in the script itself. And that way, every time the script runs, those breakpoints will be defined and they'll work. And then when you're done debugging, you can comment those out or remove them from the script. The key with all of this, though, is to keep the purpose of debugging in mind. You got to get inside your script's head. You have to have an expectation for how the script works, and you kind of have to observe the script in operation to see if how it works matches your expectation for how it would work. And wherever you find a difference in reality and your expectations, either you're wrong or the script is wrong. And don't assume it's you all the time just because maybe you're new at PowerShell. Do something to validate the problem, test things individually, and I think you'll be fine. You've got techniques for getting inside a script's head. You've got writing debug info with write debug, using ISE breakpoints, and using console breakpoints. There's lots to do. I hope this has been informative for you, and I'd like to thank you for viewing.